Hello everyone, I am recording this video to present a project that I did with E1301, which is a class that I'm taking as a sophomore in University of Minnesota. Here's an introduction of myself. My name is Tari, and I'm a sophomore in University of Minnesota, Twin Cities. I'm enrolled in College of Science and Engineering and majoring in electrical engineering. So I do owe a lot to this class E1301 for exposing me to different types of projects and leading it with a big group of like 4 or 5. I think that's big enough as top engineering projects, and an individual project that I can present to YouTube viewers, I guess, whoever watches this, and a lot of just different types of people who want to do electrical engineering for their career. I'm surprised how different approaches different individuals can take when confronting similar types of problems. That's very refreshing and in a lot of sense encouraging of my own. So I have done 2 major projects with this class. First one is this. It's an LED matrix with this is backlight glowing LEDs. It's a surface mount LED that shines light from the back of the board. This is the front part of the board, and that's how it shines the light on. Usually how it's used is you have hole instead of this little copper dots, and it just kind of shines through the board. In my case, I wanted to do copper power, which obviously I haven't done it yet. This is a bare bone part of it, but it just took way longer than I expected, so I haven't had time to quite finish the polishing. But anyway, I just wanted to have maybe just fresh copper type of board, and have a keep out layer only on like this side, maybe like a small dot or something, so the light will actually shine through only that part, even though it doesn't have like a hole in it. So it'll like diffuse the light, and it probably would have looked cool. But yeah, anyway, that was the idea. And this surface mount chip is a 44 leg surface mount chip. It's called MX6960, and that was connected to interact with Arduino. Here are some headers that will communicate with Arduino to drive this LED matrix. It plays Simon Says currently, and that was a valuable experience, and especially to know that surface mount chips are very difficult to deal with. We initially chose this chip because there's a big support community over at Arduino side, so we could easily get the library to manipulate this chip, and it also contains capacitors, resistors, and all those things to drive this whole AD matrix. So we initially thought that it would be a very neat way to do this project, especially because we already have 64 surface mount components, so it just kind of made sense that we do this whole thing as a surface mount. But it turned out to be very difficult. Anyway, so that was the first project, and now I'm gonna focus on the second project that we did in class. We each class mate had to design their own project, and in my case I decided to do an anemometer and a data logger. An anemometer, yeah, it's hard to say, is a wind speed calculator. It basically takes the speed of wind and converts it to an AC voltage, which is in direct relationship to its frequency. And a data logger is just literally a device that logs the data. So it stores the data into an SD card, and that's about it. We need a data logger that's connected to an anemometer and stores an accurate data that's actually valuable to analyze this wind speed. I have been interested in this project for a long time because I also work with this other professor outside of the class, and we are working on this project with Nicaraguan researchers. What these guys do, they're trying to build their own self-sustainable power grid because in Nicaragua, the local communities don't have electricity. They don't have the power plants usually. So what they want to do is to build wind turbines. The specific researchers that we are working with, they are building wind turbines. The thing is, I don't know how much you know about wind turbines, but they are very expensive to build because the magnet they're using are very, 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 very powerful, and that's just harder to obtain. So these the researchers in Nicaragua, and what we as my professor and I in Minnesota are doing is to build it out of scratch without any expensive devices. So for instance, instead of using very expensive magnets, we are trying to use car speaker magnets. They're readily available any part of the world, and it's just way cheaper. But the thing is, this is called poor man's design, so nobody really has done it and like analyzing it, to say the least. So it's really essential to have a reliable wind speed calculating device, and that's what I built here. And I'll go on about the circuit and the code that I needed for the data logger to function correctly. And yeah, that's about it. So let's get into the detail. Circuit. That's the end product of what we did, well, what I did. And that is basically the data logger, which is Arduino mounted with the Ethernet shield. The Ethernet shield is to write and read data in this SD card. So basically it's taking the inputs from, these are the inputs from these chips which are connected to this anemometer. That is the anemometer, and as you see, these two wires are coming out from it, and they are the signals that this anemometer is generating, and the signal is just AC voltage. So this thing is basically like a small generator, AC voltage generator, and it generates it by just turning the fan. And of course, the wind is going to turn the fan, so obviously this sine wave, well, AC voltage, is going to be corresponding to the speed of the wind. And here are some capacitors and stuff. I'll show you the block diagram and explain it in more detail. This is the block diagram, and as you see, there are 1, 2, and this is supposed to be a chip also. It's just a timer, so there was no need to go into like fine details of it. But anyway, so this chip is called LM319, and this chip is called 8736, and the timer I use 555, LM555 timer. LM555 is a very simple and common chip that you use. It's basically a digital chip that just generates a square wave that has constant frequency. The reason we need this one is to calculate the rising and falling edge, well, in this case only the rising edge of this anemometer. By the way, I'm explaining this kind of like one of the applications that you can possibly use this device. It's really up to the researcher of how they want to manipulate their data that they get from these chips. So bear in mind that I'm just kind of assuming this one particular way without much reason to it. But anyway, for explaining sake, I'll go on with that scenario. So here's a timer, and this device LM319 is basically a comparator. So what it compares is taking the signal from this anemometer. That's the NRG number 40. That's the name of the model of this anemometer. And this whole part is basically to stabilize the signal, although it's basically just a buffer that cancels out the noise. So when it comes into this chip, this raw data wasn't really polished, so to say, because this anemometer is just basically a very crude AC voltage generator. It's not going to give out a clean sine wave that is easy to analyze. So this device is gonna compare that signal to the ground, and it'll clean up some junk values that might carry out even with the buffer, and just send it straight to the timer. I mean the lab jack, which is the data logger. And this debounce circuit is for the timer, because excuse me, not the timer. It's for the signal to kind of clean out the noise just one more time, because these whole things are the electronic device. It's just destined to have a lot of noises, and because how small this AC voltage is, it's just prone to catch even more noise. But anyway, then it's gonna be sent straight to the data logger, and people can manipulate it from there on however they want. The problem with this design, this top design, is that, as I said before, the anemometer generates very low current because usually wind doesn't go up that high. It's gonna be a very small voltage, and because of that, this device can be confused very easily when it's on the very low wind speed. So in order to improve that problem, we're sending this signal to this 8736, which is a chip that calculates the RMS voltage of whatever this signal is going to send out. What RMS voltage is, if you have, let's say, a sine wave, the RMS voltage is going to be the area that it's covering in a very crude sense. But basically that's the idea. Because this voltage, again, is in direct relationship with the speed that is spinning, if you can have the RMS voltage of this signal, we can easily calculate the average speed of the wind. What I'm thinking is that we can maybe have within like 1 second, the Arduino is gonna take about 9,600 data, which is gonna be basically the voltage of it. So we can combine all of that and divide it by 9,600, which is gonna be the average voltage of this whole section, 1 second. And by displaying it, we can compare the wind speed that this anemometer spun, I guess, during the 1 second. So that's what's happening, and this device is also just sending the data straight to the data logger. So that's about it. And from there on, the researchers can do either what I just described to you, or some more clever way that they want to manipulate this. So So the code, I'm mainly gonna focus on the data logging part. So basically the part that Arduino takes input and writes to the SD card. I didn't go into detail of the manipulation of the data later on because that's totally up to the researchers, as I said before. So the code. It's a little squished view of the code because this PowerPoint, for some reason, it doesn't let me get rid of this part, this blank part. I don't know why. But anyway, well, you can still read it through, I think. So here's what I did. I included this library called sd.h. This is basically a widely supported library to use the Ethernet shield with Arduino. It has every detail of how to manipulate the SD card, and it was a very useful library in my case. And here I declared two constants, I guess. Well, this is a constant and this is not, actually. I declared two variables, let's say. So this constant int, this part is just included in the library. This is just what you have to do in order to communicate with the SD card. So this is just kind of default if you're going to use Ethernet shield. And the float refresh rate is gonna come up later on in this part of the code. It's basically how often you want to log your data to the data logger, and this can be changed however the user wants it to be. And here, the void setup, I'm setting the serial to begin at 9600 baud. So it's gonna just operate in the speed, and that's just about it with the setup. And it's gonna start print out this part. It's basically at this point we're looking at is SD card doing well? You know, is there an SD card or is there not? And if there is not, it's just gonna go card failed or not present. So there's some error between the connection of the SD card and the data logger. That's what it's saying. Or if there is no problem, then it's just gonna go ahead and print out the card initialized. And this whole part is not gonna be printed out in the SD card. It's just gonna be printed out to your serial monitor. From there on, if the card was initialized, we're gonna go onto the loop and declare the string. We're using the string because the library is using the string to log on the data. So log on the string, and from here we can go analog pin. We had 3 inputs, which was LM319 and timer 555 timer and AD736. So we have 3 analog inputs. So that's why we have here analog pin from 0 to 3. And this is just to append the string that we just created. And this appended string is just gonna keep refreshing until the analog pin hits hits number 3. And this part we just want to have like little barrier with the comma, so we can distinguish from one number to the other number. And here we finally store all the data. Then we can go on to open the file, and I'm just gonna call the file datalog.txt and file write. So we write the file. So this is just writing the string, and we close the data file because we want to use it again later on by opening it again. So we close the file, and that's about it. And I want to print, have it to print out the same data to the serial monitor also, so we can it'll be easier to debug this thing. And here again, for some reason, if the machine can't open this text file, then we'll just print out this thing. So also, this would be an easy tool, a useful tool to debug some problem if any would happen. And I delay it for that rate again. The user is going to define, so that it's not going to just give a bunch of numbers in like 9,600 numbers a second. So yeah, that's about it, and I'm gonna show you a quick demonstration of what is actually printing out on the SD card and how it's working basically in real life. Thank you for watching, and hope to see you soon. Bye bye. So here is a demonstration part of my project. Here's the anemometer, and that is the data logger, which is Arduino mounted with Ethernet cord. Ethernet shield, excuse me. Why I'm using this Ethernet shield is that it has this embedded SD card reader/writer, so it's really easy to interact with the writing SD card part, just using this. And that is a circuit. I think I explained enough in my presentation, so I wouldn't go further into the details. So what I'm gonna do, I'm just gonna spin this anemometer for a little and see what was written in the SD card. So here's a serial monitor of the data sample. As you saw, I just spinned an anemometer for a little, and it's supposed to take a data every 1 second, and that's what it did. By the way, this front part, error opening data logger.txt. So that means I didn't have the card inserted to it at that moment. And as soon as I did, it starts initializing the SD card initialized, and it just starts plugging out the data. As you see, there's some fluctuation going on here, and the way I set up my data logger is that this value is the value I'm taking from the LM319, and this value is the timer value, and that value is the RMS voltage, so 8376. So these outputs are varying because the speed of the anemometer spinning is varied, and from there on, I can manipulate the output however I want, or the researcher wants. And here is the SD card value that's taken and stored. 1 second, please. There. As you can see, they're exactly the same value as the one that I just taken on the serial monitor. So there you go. The data logger is successfully programmed, and it took the measurements that an anemometer sent us.